Tonight on Nova, bloody battles, sinister traps. Microphotography reveals hundreds of hidden worlds teeming with life. But wait, what is this mysterious creature? You know them better than you think. Crawling on your clothing, pulling on your hair, even snacking on your skin. Odyssey of Life continues with the unknown world. Nova is funded by Prudential.
Living well isn't about being rich. It's about freedom and independence and taking control of your future. So make a plan. Be your own rock.
And by Merck.
Merck, pharmaceutical research. Dedicated to preventing disease and improving health. Merck, committed to bringing out the best in medicine.
The Corporation for Public Broadcasting and viewers like you.
There is a world unknown to most of us. It exists side by side with our own. A world of radically different perspectives, where a drop of water can be home. Those who live here eat the books we prize, devour our plants, stalk each other without mercy. They even stalk us through the strange and eerie landscapes of our bodies. Tiny monsters revealed by special optics and microphotography. Our next-door neighbors. The stuff of nightmares, if we dare to look. In their world, even a head is unfamiliar terrain. And the palm of a hand is like a furrowed field. This unknown world is just too small for us to take notice. We see only our world built on our scale, large, open, and familiar. We don't even know what we're missing. In the unknown world, our chest hair is an overgrown jungle. Our scalp is a tropical rainforest. And here are the fertile hillsides of the forearm. The desolate desert of the inside of the wrist. The vast wasteland of the sole of the foot. The body we think we know is really an illusion, born of our limited perspective. Sometimes, of course, ignorance is bliss. It's not easy accepting the fact that billions of other organisms live on and in us. Most of them are bacteria like these. A microscopic swarm in a drop of sweat. Some of our closest companions have never been introduced to us. The hair follicle mite lives in holes in our scalp through which hair grows, a kind of tiny parasitic mole. It looks like a science fiction creature, but it's only 1/250th of an inch long. That's small enough to escape the attention of our nerve cells. Otherwise, we'd never stop scratching. Just knowing they exist is bad enough. The mites especially like the large follicles of our eyelashes. They thrive on fat and dirt and have even developed a taste for mascara. But for other denizens of the unknown world, there's a much more abundant food source nearby. It's our skin, constantly renewed by new cells pushing up older ones. The top layer is made up of dead, compacted cells. Every hour, we shed 1.5 million skin flakes. And each one has its own colony of hitchhiking bacteria. The air is full of these small pieces of ourselves and the microorganisms that call them home. What we see in the mirror is a layer of dead cells soon to be cast off. Still, even dead cells have their appeal.
How do I look?
Absolutely beautiful. But change the perspective, and it's a different story. When we're finally forced to face reality, we find that dead skin makes up 90% of the dust on our floors, not to mention an army of creeping, crawling creatures. This is the front end of a dust mite, seen through an electron microscope. It's about 1/80th of an inch long, impossible to see with the naked eye. Its diet is mostly skin flakes, and there are more than enough to go around. It's a never-ending feast, and we're the purveyors, like it or not. Dust mites are everywhere we are. Here we see one of them enjoying his dinner, although his table manners could use a bit of improvement. Clearly, his parents never cautioned him against playing with his food. If you think you can get away from dust mites, think again. Even in our beds, they keep us company. They move easily through the weave of blankets and sheets in search of more food. They scavenge when we're awake and when we're asleep. They are insatiable. But why not go to the source itself, our own skin? Food is everywhere, waiting to be harvested. But before you run to take a shower, consider this. Dust mites are really sanitation workers who help clean up our mess. Mites play an essential role in the ecological process, turning our biological waste into their food. So when we eat breakfast, they eat breakfast too. In fact, For every source of food, there's a group of hungry organisms scanning the menu. If we're not the specialty of the house, then something else will be.
See you tonight, darling. I'll be home by 6.
This may look like a closet, but it's really a restaurant for insect gourmets. You can tell if they really like an entree by the holes. These small white larvae of the common clothes moth are especially fond of wool and fur. When they're fully mature, these well-fed larvae will reach the final stage of their development, becoming moths who will produce the next hungry generation. But wool and cotton aren't the only things on the menu. There's also a tasty fur coat, which the fur beetle swears by. It lives deep within the fibers of the coat, and it lays its eggs there. For the yellowish-brown larvae that hatch, home is also breakfast, lunch, and dinner. They move using 3 pairs of legs and their jointed bodies. Between their eyes are powerful jaws that can saw off the hairs of the fur as their legs grip them securely. Fur beetles are discreet animals whom we seldom see. We only know they're here when we see their handiwork, especially when their favorite meal is a favorite dress. But there's no point in taking it personally. Like us, they eat to survive. Even in our prestigious halls of learning, there's a legion of ravenous creatures waiting for us to turn our backs. No door, no lock can keep them out. When we leave at the end of our day, their day begins. To these creatures, precious books are nothing but dead wood, no different from a stump or fallen branch. The subjects are irrelevant, the fine leather bindings just more organic material to break down and recycle. You wouldn't know it from looking at them, but silverfish have an ancient pedigree. They haven't changed much in 500 million years. They grow to about 1/3 of an inch long and prefer old yellowed paper. With the help of an enzyme, they break down the cellulose in paper into food. Unfortunately, they're quite illiterate and make no distinction between Hamlet and yesterday's newspaper. They like them both equally. printed page has a number of aficionados in the insect world, including the pseudoscorpion, a miniature predator always on the prowl. It lives on a diet of book lice, another lover of paper. The louse is killed by poison secreted by the scorpion's claws. Then the scorpion is off to the next victim, wherever it may be browsing. Our finest museums also have an unknown world of hungry organisms, and they're everywhere, even if we never see them. Their victims can do nothing but stare at us reproachfully. Mighty once, they are helpless now. Imagine the indignity of it. In every museum of natural history, stuffed animals, long dead, are food for the living. In the lion's fur, hidden from sight, the microscopic museum beetle is busy, admiring the taxidermist's art. The museum beetle is a close relative of the fur beetle, with similar tastes, but only half the size. It loves the protein in hair and feathers and relishes fat and dirt. It eats delicately, one hair at a time. But in the long run, it's the scourge of every curator. The museum beetle doesn't limit itself to stuffed lions. Instead, it savors all sorts of collections. Dried insects are a prime target. The museum beetle has no respect for science. A rare specimen is just another snack. A collection that took decades to assemble can be ravaged in days. Not that most of these specimens wouldn't have done the same, given the chance. But there's more here to eat than just dead animals. There's also a vast quantity of other organic material. The exhibition cases are framed with wood. And wood can be food, or shelter, or both, to a wide range of organisms. The holes signal the presence of an army of tiny wood eaters. Beneath the surface, you can find an endless system of tunnels and the creatures that make them. The white larvae of the old house borer will stick around as long as there's wood to gnaw. This is the old house borer's colleague, the carpenter ant, for whom wood isn't food, but shelter. It tunnels through the wood to make its nest. Then it carries away the chewed wood, leaving space in which to live. The result is wood destroyed from within. Business as usual in the cycle of life and death. Nothing is safe in the unknown world. Even our own bloodstream can be a highway for invaders. But that doesn't mean we have no defenses. Within seconds of a cut, a net of threads called fibrin slows the loss of blood. The net forms when a substance in the torn skin reacts with another substance in the blood. The blood coagulates with a kind of natural glue. The glue then forms a scab, which covers the wound until the skin can heal itself. Skin cells divide again and again to form the first layer of new skin beneath the scab. Other layers are then built up from beneath. The most common invaders are bacteria, one of the simplest forms of independent life. They come in a variety of shapes and sizes. They exist practically everywhere in incredible numbers. There are 100,000 billion in a human body. Not that all bacteria are dangerous. In our intestines, they play an essential role in digestion. They combine with stomach fluids and enzymes to break down food into nutrients. This salad will need their help as it makes its way through the digestive tract. But other bacteria are long-standing enemies, like the ones that attack our teeth, causing cavities and plaque. Enzymes in our saliva usually keep them in check, but if we forget to brush, the battle may be lost. Enemy manpower is unlimited. These bacteria are moving among the cells of the mouth, swimming down microscopic rivers in our mucous membranes. The bacteria thrive on the rough surfaces of our teeth, where a toothbrush can't reach. A single bacterium can divide itself into 1 million new bacteria in just 8 hours. Without our defenses, we would never survive the onslaught. But each of us has billions of cells patrolling our body. An army of soldiers often stronger than our enemies, working together on the front line. The first wave of troops are the macrophages, which literally means big eaters. Hundreds of thousands of them travel through the blood vessels and lymphatic system, ready to attack. With long, retrieving arms, they capture bacteria and kill them. Macrophages deal with invaders simply by eating them. They can tell a bacterium from a normal body cell by scanning its surface. The cell's chemical structure reveals whether it's friend or foe, to be left alone or devoured. Macrophages ultimately eat themselves to death, taking the trespassers with them. Together, millions of dead macrophages and their victims make up the substance we call pus. A macrophage will attack any foreign body it finds. Here, asbestos fibers that entered the bloodstream through the lungs are marked for disposal. Even another macrophage who's died in the line of duty is devoured. Our defender cells are always on patrol. But some invaders are more difficult to deal with than others. And some seem nearly impregnable. This is a virus, a tiny piece of genetic material surrounded by protein. Recreated using electron microphotography, they're visible here as blue dots on the surface of a cell, only 1/100th the size of a bacterium. Because a virus can't reproduce without a host cell, it isn't considered a living organism, but it can kill. It forces its way into the cell nucleus and programs the cell to make more viruses, copies of itself. This is a recreation of the inside of a cell. The red structures are mitochondria, the cell's power plants. The yellow balls are ribosomes, which make protein. But now, hidden among them, is an enemy factory hard at work. When the cell has made enough copies of the virus, it dies, and thousands of new viruses leave in search of new cells to invade. This is what happens when we catch a cold, and far worse diseases. A cell nucleus is seen here in the middle. Surrounding it are viruses. The smaller mitochondria are still working away, protected inside the cell membrane. But their fate is already sealed. Using a unique photographic process, we can now catch the viruses in the act of entering the cell. About 100 of them are grouped on the cell's surface. Then suddenly, as if on a given signal, they force their way through the cell membrane. A few days later, they leave in the thousands, just as these mast cells empty their contents. Our most important weapons against viruses are the lymphocytes. They bombard the enemy with antibodies, small molecules made of protein. The antibodies are visible as a corona surrounding the cell. But as effective as these lymphocytes are, they are no match for the viral disease we call AIDS, the most feared plague of our time. This is HIV, the virus that causes AIDS. HIV uses lymphocytes themselves as host cells to make copies of itself. So the cell we count on to kill the enemy becomes, instead, its victim. The virus spreads, and we die. This parasite causes another deadly threat, snail fever. All it takes is one misstep in a waterhole. The parasite lives in the stomach of a snail. It waits patiently for another host animal to pass by. The parasite larvae then leave for greener pastures, penetrating the skin of the foot. Inside the bloodstream, the larvae mature into worms. Stuck to the walls of arteries and veins, they feed on our blood. Here you can see the parasite's mouth sucking up blood cells. The female parasite is thinner than the male and lives attached to his body. Their eggs are then carried away by the bloodstream. They leave our body in urine, returning to the water and other snails, completing the cycle. Another parasite lives in a mosquito and causes malaria, a chronic and often fatal disease. When the mosquito bites, the parasite is injected through the skin and into the bloodstream. It lives among our red blood cells, feeding upon them and reproducing in them. The blood cells die, and the young parasites pour out to be sucked up by other mosquitoes, which then bite other victims, spreading the disease further. Parasites affect animals and humans alike. They do more damage to both than any other microscopic enemy. This fight for survival binds all creatures together: animals, humans, microorganisms. It's just that some battles are more visible. The struggle to eat or be eaten is universal, timeless, inescapable. But when it comes to the unknown world, we humans seldom pay attention if we ourselves are not at risk. And yet all we have to do is take a closer look. Beneath our very noses, we can find a myriad of creatures, like these scale bugs, who can live their lives in a flower pot on a single plant. Every inch of this greenhouse jungle is inhabited. And the same kind of drama played out on the African savanna is found here, even if the protagonists are humbler. These aphids are sucking the sap from a leaf. Here, an offspring climbs on the back of one with its siphon-like tubes. That's quite handy for these ants, who treat the aphids like cattle, herding them from pasture to pasture. The aphids are then milked of their sap. But this ladybug wants steak, not milk. It feasts upon the grazing aphids. And this red predator mite isn't just hitching a ride. Another aphid is the target of this hoverfly larva, which literally sucks out its life. All that's left is an empty shell. The large butterfly larva on the top is eyed by a land bug. He's just waiting for the right moment to strike. Now he's ready and goes in for the kill. To eat or be eaten, it's no different from the war within our body, between viruses, bacteria, and our immune system. In this case, the winner takes all. Sometimes the battle is between members of the same species. These two male stag beetles are fighting over a female. From this unique perspective, they're as fearsome as Tyrannosaurus rex. The combat ends with a lethal cut in the loser's neck shield. The winner celebrates with the female, waiting beside the battlefield. They mate, passing on their genes to the next generation. Evolution rules in the unknown world, too. The heart of the winner still beats. The fittest survive. The sperm of the winner helps shape the future. Sometimes it's animal versus animal, and sometimes animal versus plant. These ants have learned to form chains to pull together the edges of giant fern leaves. The result is a nest, food and shelter in one neat package. The fern is helpless to resist. This butterfly larva is also free to do as it pleases. But other plants can give as good as they get, and then some. Turnabout is fair play in the unknown world. This ant has picked the wrong plant to eat. Now he's the meal. There's no mercy here. Other plants have developed less deadly defenses against intruders. This digitalis leaf is really a trap for unwitting insects foolish enough to land. Each fiber has a sac of glue at the end, a sac that bursts on contact, much to the dismay of these aphids. On the potato plant, the fibers are so long that insects get tangled well above the surface. This aphid can't reach the leaf to suck up its juice. But other insects like this plant bug have come to adapt. Special claws allow it to walk across the leaf. All organisms have a part to play in this struggle, whether they know it or not. A struggle in which life itself will always triumph, even in the face of death and decay. It's true in our world and the unknown world. The more we study them both, the more we see how similar they really are. The only difference is one of perspective. If we choose, we can see nature through the eyes of a rhinoceros beetle and be grateful we aren't his size. We can see the garden as an obstacle course. We can change our entire sense of scale and imagine ourselves as the worm instead of the farmer. We can learn to look beneath our feet, to see the small, the overlooked, the insignificant. Unusual teachers with different points of view. we can find a new way of looking at life, one that's more down to earth. We can even learn more about our own past from the unknown world. In every pool of water, there are tiny organisms whose beginnings are linked to ours, distant relatives to the cells that make up our bodies. They tell us how life developed and flourished. Representatives of the first primitive life forms that led to all the creatures on Earth. The unknown world can also teach us how our own bodies function. Like us, the water flea reproduces through live birth, a microscopic version of our own reproductive system. Above the eggs of the next generation, we see her narrow green digestive tract and her beating heart. The processes of life that govern us can be found everywhere, on the very ground we walk. Sometimes we're the ant, and sometimes the beetle. The trick, of course, is to be the predator, not the prey. The trick is to live another day. The tunnels of insects can provide a model of our circulatory system. Arteries in the soil, making possible the flow of nutrients. An earthworm can help us understand our immune system. Inside, the same struggle between attacker and defender. On the forest floor lie clues to our own digestive system.
I'll get you. Oh, no.
Hey, I'm coming.
Oh, no, let's look at him here. Yeah.
Here, dead plants and animals are broken down by the living. In the soil of just one footprint, there are millions of decomposers hard at work. Up above, the cycle of life takes another turn. A new generation must always replace the old. The dove may not ponder the processes of life and death, but its fate is the same, nonetheless. There is only one direction in which to fly, no matter how extraordinary the journey. Just as life has sent us on our way, death awaits us all, the mite, the dove, ourselves. But the end of the story is also the beginning, as insects and bacteria turn death into life. Flies lay eggs that hatch into larvae. Ants, wasps, and beetles arrive on the scene along with others. Watch as a process that takes a few weeks is compressed into 30 seconds through time-lapse photography. In 14 days, what was once a beautiful dove has been broken down by an army of organisms until only a pile of feathers is left. And yet everything remains in a different form. Other animals and plants are using the dove to build new life. Here, over 5 weeks, in the same small patch of ground, spring flowers grow and bloom. And when they die, there are always others to take their place. The soil passes on what it has gotten, only to get it back again in an endless cycle. A cycle of water and nourishment. A cycle of day and night. A cycle of seasons. Every day, our world and the unknown world meet. They meet on our teeth. They meet in our museums. They meet in our bloodstream. For better and for worse. They meet wherever we are. And so it becomes clear that our world and the unknown world are really one and the same, and we are all in it together.
Take a closer look at the technology that's given us a closer look at ourselves. From motion studies to fiber optics, zoom in to NOVA online at pbs.org. To order this show for $19.95 plus shipping and handling, call 1-800-255-9424. And to learn more about how science can solve the mysteries of our world, ask about our many other NOVA videos. Tomorrow night on NOVA, meet the man behind the camera and discover the secrets at the heart of his greatest work. Leonard Nielsen revealed on Odyssey of Life, Part 3, The Photographer's Secrets. Nova is a production of WGBH Boston.